Okay, here's a handout I use with one of the other classes I teach. So I'm going to go over this again with multiplication and counting and stuff. For example, if you can repeat, that's a big thing. If repetition is allowed, we use multiplication principle. So combination lack, let's see, 3 digits. So you could have 0, 0, 0, 8, 8, 8, maybe wouldn't be a good choice. You could have 8, 9, 8, something like that. Notice there are 10 numbers, digits, 0 through 9 is 10, but you have 10 choices, 10 choices, 10 choices. So there are 1,000 different ways that could happen. If you're not allowed to repeat, okay, you can still use this if order matters, okay? So here order would matter. So I have 3 number or letters, right? So pretend I have ABC. 3 choices for that letter, 2 are left, 1 in that. There should be 6 ways of doing that. Now again, with letters, BAC, CAB are 2 different words, okay? And so if order matters, we call that a permutation. And so I could go on my calculator, I have 3 letters, and then I'm going to go to math and on my calculator probability. In my other video, I showed you how to find this on Desmos and on a different calculator, permutation. And I want to choose what, all 3 of them. So there's 6. So that's another way of doing that. But you can use the multiplication principle as long as, you know, order matters. How many can you arrange books on a shelf? And remember, arrangement is like art. And in art, order matters because I might want my book front and center or something like that. So again, I could do, what is 5 books? 1, 2, 3, 4, 5. So I have 5 choices, 4 left, 3 left, 2 left, 1 left. Okay, 5 times 4 is 20. What is that? 60, is that 120, I think? Different ways. And again, because order matters, because it's art, this would be a permutation of what? 5 choose 5. And you could do that on your calculator and get that. Okay, the other thing you could do is make a tree diagram. This one I would not want to. This one wouldn't be too bad, but you know, just depends on. So let's see. So usually these are number ones that can repeat, or like how many outfits or how many different food combinations. All right. So if I want, I have what, 4 pastas and 5 sauces. There would be, you know, 20 different combinations. But again, that's if you have 1 and 1. If you can do 2 things or 3 things, that changes everything. All right, let's look at the back. And again, these are called factorials. So like this is 5 factorial means 5, 4, 3, 2, 1, right? 5 factorial. If I give you 10 factorial, it'd be 10, 9, 8, 7, all the way 2 times 1. Go all the way down, okay? So let's see, playlist, order would matter usually if you want to, like music is kind of art. So I want to design a playlist of 7 songs. Again, if I don't repeat any, you could do 7, 6, 5, 4, 3, 2, 1, and, or you could do a permutation 7, choose 7. Most of you do have a permutation key or a factorial key. So for me, if I go to math, and I go over to probability, I have a factorial key. But if I know order matters, I'm going to use a P thing. If I know that it doesn't, I'll use the other one. All right, 9 in a race. Again, first place, second, third, fourth, order matters. So 9 for the winner, then 8 left, 7, 6, because these are the people still running, right? 5, 4, 3, 2. Now, after that person gets that place, right, there's only 1 person left to get, you know, kind of last place because they're the only runner left. This would be, again, order matters in a race. It's a P, 9 choose 9. All right. Now, here's some permutations. Okay, so in a permutation, you could do the counting principle. That works with order matters, or you can do this, okay? Either one. All right, they both work. Let's see. Okay, so here we're looking for first, second, and third choice for president. We're not picking everybody. So if you want to do the counting principle, you would have how many choice? 8 candidates. But you only want the first 3, right? So first place, there'd only be 7 left for second place and then 6. And you would not go all the way down to 1 because you only have first, second, and third choice and you're ending. If you want, order matters because again, first, second, and third, it depends on who comes in, you know, first. Like ABC means A is first place. CBA means C is first place. So it changes when I move things around. That is a permutation if order matters. And we have what, 8 people. And I am just choosing 3 of them. So again, on Desmos, you would do this. On Desmos, it would look like this, P, NCR, but you do the 8, 3 after it. And it's under the function area of Desmos. And again, in a previous video, I talk about that. Otherwise, on this calculator or the cheaper one, like the $15 one, you guys have that probability key, but I have to find my probability down there. And this is a permutation because order matters. 8 choose what? 3 candidates. I get 336. But notice that should be the same. Yep, doesn't matter. So on permutations, you have the choice. All right, let's see. Okay, how many ways can you arrange? This is called, and I didn't talk about this in the previous one, it's called distinguishable permutations. The problem is, like if I have ABC and CBA or what, BAC or what haven't I done yet? BCA, C, AB, what's missing? I have 5. I need one more. A, C, B. Those are the 6 ways I can arrange those 3 letters. But if you have repeats, the problem is like Mississippi. If I move the order around, you can't always tell. Like if I move these 2 P's, you're not going to know it. If I move these 2 S's, you're not going to know it. Or if I move these 2 I's. So the problem is they have to be distinguishable, meaning they have to look different. Here, all 6 ways look different. But if you have repeat letters, not so much. So we have a formula for that. N factorial is all the letters. So Mississippi has 11 letters, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 factorial. And then these are all your repeat letters. So what do I have? I have 4 S's. So those are for my S's. I have what? 2 P's. How many I's? 1, 2, 3, 4 I's. Do I have any other repeats? I don't think so. I just have 1 M. You could put 1 factorial. It's not going to hurt anything. But then what you can do is on your calculator, you could take 11 factorial. And then again, if you want to do this in one swoop, do this extra parenthesis. If you do Desmos and it's in the denominator, it will separate the math. The other thing you could do is do 11 and go to probability and do factorial. But if this is super big, it might not like it. 399168800. Okay, and then you could do 4 probability factorial, which is what? What's that? 24. So this is going to be 24. 2 factorial is 2 times 1, so that's just 2, and then another 24. So what is that? 24 times 24 times a 2 and times a 1 is what? Or you could do this. And again, if you have the simpler calculator, you just have a probability key right on your normal screen. All right, and then I could divide these. So 399168800 divided by, okay, and I got 34,650 for the number of ways I could make new words using all 11 letters. Okay, so for like moon, it would be how many letters total? N factorial. There are 4 letters, 4 factorial, and then divide by any repeats. Well, what are they? The only repeat is O, and I have 2 of those. So I have 4 times 3 times 2 times 1. So if you don't have a good calculator, you can just multiply it out. So I could take 4 factorial, which we know is what? 24. 2 factorial is 2 times 1, which is 2. I should get 12. The other thing you can do is if you write out the factorials, like this is 2 times 1. Okay, get rid of that. Then you could cancel. Okay, and that's what you do when you have really big numbers that your calculator doesn't like. Like if you have like, I don't know, 99 factorial divided by 98 factorial, your calculator is probably not going to be able to do it. But if you think of 99, 98, 97, all the way down to 1, 98 is 98, 97, all the way down to 1. You don't even really need a calculator because do you see how all those guys are going to cancel and you're just going to end up with 99. So, you know, sometimes that factorial is just way too big for your calculator to handle. All right, let's see what else we have for counting. I think that's probably the biggie on that one. Okay, so combination is, again, when order does not matter. This is the formula, but again, you can just use these keys on your calculator. So this is when order doesn't matter. And I don't know that there's a ton of these on your homework, but say that you have a committee, okay? You can't just use the multiplication principle because in the multiplication principle, order matters. In a committee, it doesn't. So if I have Ann, Bob, and Carl, or Ann, Carl, Bob, or Bob, Ann, Carl, Bob, Carl, Ann. What else do I have? Carl, Ann, Bob, Ann, Carl, Bob, Ann. If these are different, like president, vice president, secretary, this is different elections. But if I just want a committee, do you guys get these all 6 are the same committee? Like they all have Ann, Bob, and Carl on them. So like, who cares? So if order does not matter, it is a combination, and you cannot use the multiplication principle. So this is when order does not matter. So then it would be combination, and I have what, 8 people, and I just want to choose 3. But see, I don't want to count these 6 as different. I want to count them as all the same. So on my calculator, I would type in E for, or 8 first, sorry, go to math, find the probability key. I'm going to choose a combination, and I want to choose 3 people, and I get 56. Okay. And so really another way of doing that, I don't know if you want to get into this, but the way the formula works is it kind of does like 8 factorial, like everybody's in there. So 8, 7, 6, 5, 4, 3, 2, 1. That's like everybody's on the committee. And then, but you only want 3 people to be on the committee. So you cancel out these slots because you don't want those choices. But then the problem is you have to divide by 3 factorial, 3 times 1, because to get rid of the double counting. And that's what this formula does for you, that this part right here gets rid of the double counting, but it's probably just easier to use the formula. Okay, we don't have tons of time in this class to develop it. Okay, notice if these were up for jobs like president, vice president, secretary, suddenly it would be a permutation. Okay, salesman has to visit certain cities. If they don't care the order, right? Sorry about that. It's 10, choose 2, and it's a C. Okay, it's a C one. So I would, because order does not matter. So I'm going to go to math, probability, and again, I have in my other video, I show you how to do decimals to get that 45. Okay, let's see. So again, the big ideas here are, and again, you can use the keys. You don't have to know those formulas, but here, order matters. Here it doesn't. Here, again, when you use these formulas, no repetition is allowed. No repetition is allowed. Okay. If repetition is allowed, then we always use a multiplication principle. Okay. So like, you know, if you have, you know, 7 choices, 7 choices, 7 choices, 7 choices, because nothing goes away as you pick it, that's always just a multiplication principle. Okay. But if, you know, if you can't have repetition where you go 7, 6, 5, and then 4 choices and maybe 3 choices, 2 choices, 1 choices, then we're kind of down in here. Okay. Yes, you can use a multiplication principle for this guy. You just get rid of the slots you don't want. So if you're only going to pick the top 3, you know, you might not have these guys. But again, that still implies that order matters. If not, you're over here. All right, let's see what else is possible. All right, let's start a little bit of intro to probability. Okay, probability is just, it's kind of this formula, but it looks kind of funky. It's like set notation. It's how many sets, how many answers are in, you know, your event that you want to happen out of the total number of sets, okay? Like the number of answers, okay? And I think it's probably easier for me just to do an example on paper for this. All right, so for example, say I have marbles and I have a red, a green, and maybe 2 blue. Okay, say you're gonna pick 1 marble, just 1. Okay, so I'm gonna close my eyes and I pick up marble. What is my probability of getting red? Well, how many red ones are there? 1, 2, 3. That's the number of elements in my event, because my event is pick red. So I have 3 chances to pick red out of my total number of chances, which is 6. So I have a half or 0.5 or 50% if you multiply by 100 probability. Okay, what's my probability of blue? Well, how many blue do I have? 2. Out of how many chances to win? 6. That's a third, which is 0.33, 33%. And then probability, what other color do I have? Green. Probability of green is how many chances to win? 1 out of 6 total, which I believe is 0.1. I think just, I gotta check. 1/6. That would be, yeah, my brain isn't there. Yeah, I'm right. Okay, 16.6 repeating percent. Sometimes Sunday morning, not really with it today. All right, probability. Notice these should all add up to 100%, but sometimes with rounding, because technically this is repeating too. So we get a little dicey there sometimes, but it should add up to 100%.